Alright, the next thing we're adding in is horizontal asymptotes. They describe the end behavior of our graph, so the far right and far left of our graph will always extend towards and approach that horizontal asymptote. They're going to be y-equals equations because they're horizontal lines. A graph can actually cross a horizontal asymptote, but it doesn't necessarily always cross it. Sometimes it'll cross, sometimes it won't, but the ends always approach it and don't cross it at the end points. So, looking at our first example, actually let's describe our horizontal asymptotes. So when we're looking at our rational equations, we've got a to the x over m plus all the rest of the graph over b to the x, bx to the n. This is an m, this is an n. I know it's hard to see. When we look at this, we're going to look at the exponent of our leading coefficient, so the highest exponent. If the exponent on top is smaller than the bottom, so your bottom exponent is bigger. So if the bottom is bigger, then we're going to have a horizontal asymptote at y equals 0. If the top and bottom exponent, so if both the exponents are the same, so if m is equal to n, then we're going to have a horizontal asymptote at the ratio of their coefficients. So if we have 3x over 2x, we'd have a horizontal asymptote at y equals 3 over 2. If we have 2x squared over x squared, since we have a squared and a squared, our horizontal asymptote would be y equals 2 over 1, or just y equals 2. So if they're the same, you're going to use the ratio of their coefficients. If the top is bigger, so if your top is bigger, then we have no horizontal asymptote, so you'll just write none. So the only time we have horizontal asymptote is the bottom is bigger, it'll be at y equals 0. If they're the same, then it'll be the ratio of the coefficients, the numbers in front. To me, the easiest thing to do is to start with your horizontal asymptotes, because once you start factoring and canceling things out to find your wholes, it's going to be harder to see what your exponents are. So in this first one, we've got 2x over x. These both have an exponent of 1, so they're the same, which means we're going to use the ratio of their coefficients. So this would be 2 over 1. So it would be y equals 2 over 1, which is just y equals 2, would be my horizontal asymptote. The rules for finding your domain, vertical asymptotes, and wholes are the same as before. So we've got 2x over x minus 5. I'm going to rewrite it since I scribbled on it. We don't have any squares, so there's nothing to be factored out. We notice what makes our bottom 0. That would be 5. So our domain is negative infinity to 5, union 5 to infinity. Vertical asymptote, nothing cancels out here, so this is going to be a vertical asymptote. So it would be x equals 5. Again, nothing cancels, we don't have any wholes. When we look at example 2, here on example 2, we've got x to the first power over x to the second power. The bottom is bigger, so when the bottom is bigger, it's going to be at y equals 0. So horizontal asymptote is y equals 0. Now we're going to go into our factoring. We've got x plus 3 over x plus 3, x minus 3. Things that make my bottom 0 would be negative 3 and positive 3. So least to greatest, negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. When we simplify, x plus 3 and x plus 3 cancel out. Because they cancel out, this would be a whole. My other one is left over, so that'll be a vertical asymptote. Vertical asymptote is x equals 3. Our whole is at negative 3. Again, to find the y value, we're going to plug into what's left over. Well, here, my leftover, I don't have anything on top, so we use a 1 to hold the place. X minus 3 is on the bottom. So if we plug in 1 over negative 3 minus 3, we 1 over negative 6, or negative 1/6. So negative 3, negative 1/6 is where my whole is located. Third example. Here we've got x squared over x. My exponent on top is bigger, so when the top is bigger, we have none. So there are no horizontal asymptotes. Go ahead and factor. They both have a 2 and an x. We're leaving with x plus 4 over x plus 4. These cancel. Here, this makes it Negative 4 makes it 0. That's also going to be a whole. So the only thing that makes my denominator 0 is negative 4. So negative infinity to negative 4, union negative 4 to infinity. Vertical asymptotes, there's nothing left over, so there are no vertical asymptotes. We have a whole at negative 4. What's left over is just 2x, so we're going to plug in 2 times negative 4, which would be negative 8, is where my whole is located. So again, just to recap, when you're looking at the exponents, so the exponents before you do any factoring, the top is bigger, you have no horizontal asymptotes. If the bottom is bigger, then it's at y equals 0. If they're the same, then you're going to use the numbers in front, and that'll give you the equation of your horizontal asymptote.